astrobiology is pushing back the boundaries of modern science. Researchers now have the technological instruments to locate exoplanets. These are planets that exist outside our solar system. Exoplanets need to pass several tests in order to be considered suitable for Earth-like life. Most importantly, they need to be within a habitable zone of a central star like our Sun in order to support liquid water. NASA plans to launch a space telescope to search for terrestrial Earth-sized planets. The spacecraft's instruments will be able to detect exoplanets by measuring changes in a star's light curve as a planet passes between the star and the spacecraft. Jeff Marcy is one of the world's leading planet hunters.
We would estimate that there are some 50 billion, maybe 60 billion Earth-like planets within just our Milky Way galaxy alone. And remember, our Milky Way galaxy is just one of hundreds of billions of galaxies out there, more or less like our Milky Way. So the number of Earth-like planets in our universe is a nearly uncountable number.
But locating exoplanets is only half the battle for an astrobiologist. In the next 20 years, NASA will launch the Terrestrial Planet Finder. This collection of highly sensitive space telescopes will actually recognize if a planet has the right atmospheric gases, such as water vapor, carbon dioxide, methane, and ozone, all necessary to sustain Earth-like life. When it comes to producing larger Earth-like life, a planet or moon needs oxygen. 3.4 billion years ago, the only life on our planet were single-celled microbial organisms. But as this primitive life absorbed energy from the sun, it formed a green pigment called chlorophyll. This produced photosynthesis, a chemical process which converts carbon dioxide and water into energy, with oxygen as a waste product. Single-celled organisms evolved into cyanobacteria, one of the Earth's earliest structures. Cyanobacteria injected vast amounts of oxygen into the oceans and air. New life emerged, which diversified and developed into large multicellular species, and eventually man.
Our Earth would not have oxygen in the atmosphere if it were not for plant life, by photosynthesis generating the oxygen that otherwise would oxidize rocks and vanish. So oxygen is a biomarker for the Earth. If we could examine another Earth-like planet and detect oxygen in its atmosphere, it would be one key sign, not yet definitive, but one element of the argument that that planet too has photosynthetic life.
At NASA's Ames Research Center, astrochemist Lee Bebout and her colleagues are cultivating oxygen-bearing ecosystems in a greenhouse. They're microbial mats, complex microbe communities often found on muddy and sandy sediment surfaces, in hyper-salty waters and carbonate beaches. These microbial mats are the oldest known living ecosystems on Earth. Bebout wants to know if these microbes could exist on other planets, producing oxygen, thereby enabling life to evolve. If life exists far off in our galaxy, or in distant galaxies, will it truly be Earth-like? On our planet, all life contains DNA, a long chain of molecules that holds the blueprint for every living thing. It allows life to duplicate and branch out, essentially creating the tree of life. But are there alternatives?
Maybe life on another world is still carbon and water-based, but doesn't use DNA at all. Maybe it uses a completely different type of molecule to store information. That would be very exciting.
And could there be life that doesn't require DNA, carbon, or water?
But maybe that ours is kind of a crappy planet compared to what's out there, that there may be other planets that are much more optimized for advanced life.
Many of my colleagues, which are doing astrobiological research, they're looking for life that unkindly I might typify as stupid life. And they're looking for microbes mostly. There may be something a little bit bigger.
Some astrobiologists want a close encounter with something more than just a microbe. They're looking for intelligent life that's perhaps even smarter than us. The search for life extends beyond looking for slimy bacteria. In astrobiology, a crack team of scientists wants to make contact with something much grander.
SETI, of course, is looking for intelligent life in space, but it doesn't just stop there. They have to be not only intelligent, but they have to be technologically competent.
The Search for Extraterrestrial Intelligence Institute, better known as SETI, uses radio technology to listen for radio leaks from alien civilizations. It's based on the premise that humans need to communicate, so perhaps alien nations also want to get their message out.
What we try and do is simply try and eavesdrop on signals, either radio waves that we could pick up with our antennas, or flashing laser lights. They might be using big lasers to aim pulses of light in our direction.
SETI has been listening for signals since the 1960s, but ET hasn't phoned in. This silence has fueled skepticism.
Now we're going to find lots of planets with life. I'm guessing that intelligence will be rare, but they won't be smart in the way that humans are smart. That's going to be rare. But again, that's just my intuition.
Aliens can't get here at faster than the speed of light. Physics doesn't allow that. And that means since we've only been broadcasting for, say, 60 years, they can't be coming from a planet more than 30 light years away. Well, the number of stars within 30 light years is pretty small.
Our universe is over 12 billion years old. Planet Earth has only been around for over 4.6 billion years. Therefore, there are planets millions and billions of years older than us. So if there's life beyond the Milky Way galaxy, it potentially could be millions to billions of years more advanced than us.
I think that the truly intelligent species out there, if they ever happened upon us, would maybe regard us as we regard ants or bacteria, as some primitive example of life. Anybody we meet is going to be much more advanced than us, at least certainly much more aged than us in terms of how long they've been a civilization.
If intelligent civilizations do exist beyond Earth, what would they look like?
And if we find intelligence in space, it's moved on beyond biological intelligence, and moved on to machine intelligence. A thinking machine that represents a million years of evolution beyond where we are. Who knows how it's built? All you know is that it might be really, really smart.
There's no logical reason why there shouldn't be machines from other worlds exploring our planet, coming into our airspace, maybe even attempting to interact with us in some way.
Whether we find a trace of bacteria or a high-tech civilization, any discovery of life will revolutionize the way we think about the universe and ourselves. Until then, it remains one of the greatest unsolved mysteries of all time.
So we're going to see a real zoo out there when we finally do discover alien life. All sorts of different ways of coding information and making molecules, causing the phenomenon of life.
The people that work on this field are geeks, so we imagine making contact with alien geeks, right? And that we're going to have fun talking about equations together. But maybe we'll end up making contact with alien hipsters or bohemians, and we'll need some other form.